beteken hy het 'n x tot die mag 3 in. So far we've been working with the x to the power of 2, which forms a parabola. But we are working towards this, a cubic function, which means that the equation of this will have a x to the power of 3. Okay, goed. Sien julle dat die gradiënt van daai lyn heeltyd verander? The gradient of that line isn't a constant number. If we go and we draw a tangent, do nou. If we go and we draw a tangent at this point, let's say that is at x equal to -2. Then the gradient of that straight line will be different than a tangent that I draw here. Let's say that's at x is equal to 3. Okay? So sien julle, soos wat ek met die grafiek aanbeweeg, verander die gradiënt van my grafiek die hele tyd. And that is why when we're getting the gradient of this line, we can't just get a number, because the number is going to change the whole time. So what we do is we get an expression for the gradient of the line. And then as your x values change, your gradient changes as well, because you then substitute that x value. And I'm going to do a example like this with you guys now. I just quickly want to show you what will the gradient be over here. Wat is die gradiënt van 'n horisontale lyn? 0. Nee? Stem julle saam? Die gradiënt van daai lyn is 0. En dit is waar vir alle draaipunte. And that is how we are going to calculate the coordinates of a turning point. We're going to get the expression for the gradient and we're going to set it equal to 0. Crazy. And this works for parabolas as well. So you never have to do the -b over 2a thing again, because this is easier. You'll see once we've done a few, it's easier. Okay. But the important thing that you guys must understand is that when we are getting the first derivative, you are also getting the gradient of the line. Maar ons kan nie meer dink aan gradiënt as net die gradiënt van hierdie lyn is 4 nie. Die gradiënt van hierdie lyn kan nou iets wees soos 2x plus 8. En dan verander die waarde van x soos wat ek met die grafiek aanbeweeg. Because not all graphs have a constant gradient. So the gradient changes as the x value changes. But it's important that you guys take note of that. Die afgeleide van die funksie gee vir jou die gradiënt van die funksie, which will not always be just a number. Okay. Good. If you page over, they start with the differentiation rules, and I'm going to go a bit off script there. It's almost, if you count it like this, if this is 1, 2, 3, that's an exercise, or the rest of exercise 1, 4, it starts there at the top. Okay, so this is the basic rule, but it's much easier when you're working with actual numbers. But let's do the basic rule anyway. As die grafiek is ax tot die mag n, so sort of look like look at the x as like an anchor. We're not going to change the x. We're going to manipulate the a and the n. Okay? The x is your anker. Jy werk rondom hom. Then the first derivative of that will be n times a x to the power of n minus 1. X is your anker. Okay, and you guys saw now when we got the first derivative of 5 that it fell away. But you guys don't need to understand the maths behind it. Just know this. Die afgeleide van 'n konstante is 0. And then ons praat van grade in funksies. So x tot die mag 3 se graad is 3. X tot die mag 7 se graad is 7. It's always going to decrease 1 if you get the derivative. Because we do this. Okay. En dan hierdie volgende reël is so half maar partykeer is dit moeilik om raak te sien. Die eerste afgeleide van enige iets wat staan voor 'n x tot die mag 1, dan bly net daai getal oor. So let's say we're getting the first derivative of 2x, then it'll be 2. If we get the first derivative of minus 8x, then it'll be minus 8. So when you get, because then you're saying 1 minus 1. Wat 0 is, en enigiets tot die mag 0 is 1. But it's almost easier to just study that. Okay, so ek gaan daai voorbeelde saam met julle op die bladsy deurgaan. Maar ek wil hê julle moenie daar kyk nie, werk saam met my. So as ek vir jou sê f van x is gelyk aan x tot die mag 5. Use the x as your anchor. Wat staan voor die x? A 1. Né? So then the first derivative, you're doing two things. You're multiplying two things with one another, and then you're subtracting one. So let's multiply first. Wat gaan voor my x staan? 5. Write down your x to the power of 4. Where did we get the 4? 5 minus 1. Is that? Or you can follow that whole method we did earlier, but this is a lot easier. Okay, so when we're doing differentiations, always, except when they specify that you're doing it by using the first principles, you use this. Okay, so daar gaan een som in die vraestel wees wat hulle vir jou sê, kry die afgeleide deur gebruik te maak van die eerste beginsels. Dan doen jy daar hele f dash x is gelyk aan limiet la 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 la. Everywhere else you are using the derivatives, you do it like this. Okay, goed, nog ene. Ek gaan nou ene opmaak, want ek dink julle het net op die bladsy gekyk. Use the x as the anchor. If you think you know the answer, write it down. Nou sit julle almal eers daar. Want to tell me what the answer is? Sorry? I'll show you the answer. 28? X to the power of? Good. Where did we get that? 7 times 4 and then 4 minus 1. Did you know? Yes. We're going to do that later. So when they give you the first derivative and you have to work back. Yeah. But let's do this first. Okay. Yeah. Sort of. Sort of. Okay. Ek gaan nou maar net opmaak heeltyd want anders dan kyk julle net op julle bladsy. Ek ken vir julle. Why always the fractions, man? You can still multiply a fraction. Yeah. No, man, guys. All of you reaching for your calculator for a quarter times 2. What's a quarter times 2? A half. Sorry, ma? 1. I don't have to write the 1. Okay. Take it term for term. So first do 4x to the power of 3. Kla. Then do negative 2x to the power of 2. Kla. Ay. Liam, what is it? The first one. Do you guys see that it decreases each time? Ne? Next one, Liam. Plus 3. The negative 1 falls away because it's a constant. Die afgeleide van 'n konstante is 0. So I fall weg. And anything standing in front of just a x to the power of 1, like this, die afgeleide daarvan is dan net 3. Okay. Guys, it is going to get more complicated than this because I'm not going to give it to you just that. But what did we do now? This is the equation of a third of a cubic graph. Okay, en wat ons nou gedoen het is ons het gesê sy gradiënt kan ons uitwerk deur dit te gebruik. So let's say I'm asking for you for the gradient at x is equal to 2. Then you just go and substitute 2 into x. So you get the derivative because the derivative gives you the gradient. And then you substitute the value that they're looking for in. So kyk gou vir my terug waar hulle staan 1.5, eintlik 1.4 ook. Hulle sê vir jou bepaal die gradiënt van 3x² by die punt x is gelyk aan 4. So they ask you to determine the gradient of f of x is equal to 3x² at that point. Okay. First thing we do is we get the first derivative. Wat is die eerste afgeleide van daai? Okay, now remember this. What type of a graph is this? Julle ken hom. It's a parabola. And do you guys agree that when I'm drawing a parabola, daai in 'n vorm sal mos so iets lyk?